Hello everyone, my name is Sapon Kojokwachi. Today my group members and I are here to have a presentation on computer architecture. And we are going to discuss on the following topics. Topics are as follows. We have instruction cycle, instruction format, fetch, decode, execution cycle, and interrupt. Instruction cycle. Instruction cycle is a fundamental process that a computer central processing unit follows to execute machine instructions. It is the sequence of steps that a CPU goes through to fetch an instruction from the memory, decode it, and then execute the corresponding operation. The instruction cycle is crucial for the proper functioning of a computer CPU and is a fundamental concept in computer architecture. Here are the stages of instruction cycle. We have the fetch, decode, execute, and write back. Fetch is the stage of instruction cycle, and at this stage, the CPU retrieves the next instruction from the memory. The memory address of the instruction cycle to be fetched is usually stored in a register called the program counter. Decode is the next stage in instruction cycle. In this stage, the fetch instruction is decoded to determine the specific operation that needs to be performed. The CPU identifies the opcode into brackets, operation code of the instruction and any associated operands that might be required for this operation. Execute is the third stage in instruction cycle. In this stage, the actual operation specified by the instruction is performed. This might involve arithmetic and logic calculations, data manipulations, data transfer between memory and registers, and more. The specific execution depends on the type of instruction being processed. Write back is the last stage of instruction cycle. In this stage, for instructions that are produced as a result, example as arithmetic operation, the results are written back to the appropriate registers or memory locations. This stage is sometimes included in the cycle, especially in a more detailed description.
Hello everyone, I'm Ephraim Class Peters, and I'm here to add up to what my fellow colleague or my group leader just discussed with you guys. And I'm here to talk about instruction format. Now, when we say instruction format, what are we saying about instruction format? In computer architecture, instruction format used in the context of a computer program and how a processor executes the program instructions. They can also be referred to as sequence of bits that defines the layout of a machine instruction for the CPU to decode and execute. Now, this whole concept of instruction format, it's related to how computer processors decodes and executes the program machine instructions. Now, when we say the computer processors, we are referring to the CPU, that is the central processing unit, which is also called the brain of the computer. It provides processing power to the computer system. It controls all the operations performed by the computer system, including the activities necessary to execute the program. The CPU decodes and executes the program instructions based on the instruction format. Now, the whole purpose of the instruction format is to provide a systemized structure for machine instructions in computer programming. It helps the computer hardware understand and execute the instructions correctly. By defining the layout and organization of instructions, the instruction format enables efficient communication between the software and the hardware components of a computer system. Now, let me elaborate this purpose of the instruction format to you guys. The instruction format helps the central processing unit to find out which operation to be performed, as in where is the data located, how do you reach the data. The instruction format also provides all this information to the processor in order to execute this instruction. In order to execute the instruction, the CPU or the central processing unit needs to know these three things. My fellow colleague is going to enlighten you on the following three things. Thank you.
is Richard Awudo, and I'm here to continue what my teammate started, which was interaction format. And in interaction format, there are three main components. One, address mode. Think of this as how you tell the computer where to find the number you want to work on. Two, opcode, which is also known as operation code. Imagine this like a recipe card that tells the computer what kind of task to do, like adding or saving. 3. Operand specification. This is like describing the numbers you want the computer to use for the task, whether they are in boxes or in right away, or they are in it right away. Okay, let's go. So types of instruction format. These are some of the types of instruction formats. 1. Single accumulator format. In this format, instructions operate on data stored in accumulator registers. 2. General register format. Instructions in this format include 2 or more registers. 3. Memory format. This instruction involves a memory operand and 1 or more registers. 4. Register memory format. Similar to the memory register format, but the register operands and memory operands are reversed. 5. Memory format. This instruction involves operations between two memory locations. The opcode, which is also known as the operation code, specifies the operations and the operands are memory addresses. 6. Immediately, which is also known as immediate format, includes immediate values in instructions. 7. Branch format, used for branching or jumping instructions. 8. Vector format, which performs operations on multi-data elements at once. 9. Floating point format is a type of instruction format for floating point arithmetic with precision controls. 10. SIMD format, which is also known as single instruction multiple data. It enables parallel data processing. And 11. Complex instruction format, which is used in CIS architecture with variable length instructions and diverse address modes. Thank you. This is all what I have for you on instruction formats. Thank you.
Guys, today we'll be talking about interrupts. Just as we human beings, we need water to survive. That's the same way when it comes to computers. Interrupts help their daily activities. An interrupt in computer architecture is a signal that temporarily stops or holds the normal execution of a program and transfers control to a specific routine called interrupt handler. Interrupts play a crucial role in managing and prioritizing tasks in a computer system. When an interrupt occurs, the processor saves the current state of the program being executed and jumps to the interrupt handler. The interrupt handler then performs a specific task related to the interrupt handling output operations, or responding to hardware event servicing requests from other programs. Okay, so in addition to what I said earlier, interrupts enable devices to communicate with the processor, reducing the need for continuous polling and improving system responsiveness. They also facilitate error handling and exception handling, allowing the system to recover from unexpected events or errors gracefully. Overall, interrupts are fundamental concepts in computer architecture, but not only in computer architecture, but in computers themselves. They enhance efficiency, responsiveness, and functionality of computer systems. To end a topic on interrupts helps us stay organized, responsive, and adaptable in our daily lives. Thank you very much.
Hello guys, today I'll be taking you through the fetch, decode, execute cycle. That's the FDE. It's a fundamental concept in computer architecture that describes the basic operation of a central processing unit in a computer. It consists of three main steps. One, we have the fetch. In this step, the CPU retrieves the next instruction from the memory. That's the central processing unit, the PC or the central processing unit keeps track of the memory address. So it fetches the instructions located at the memory address. Two, decode. Once the instruction is fetched, the CPU decodes it to determine what operation it should perform. This steps involves the interpretation of the code. That's the opcode. That's the operation code of the instructions. 3. Execute. In the execution step, the CPU performs the operations specified by the decoded instruction. This may involve arithmetic or logic operation, data movement, or control flow changes. So after the execution step, the program is updated to the next instruction in the memory. So the cycle repeats itself after the execution step. The fetch, decode, execute cycle is the foundation of how a CPU processes instructions and performs tasks in a computer program. It's a key concept in understanding how a CPU operates at the machine code level. Now we will know why the fetch, decode, execute is fundamental to the CPU. 1. Instruction execution. The FDE cycle is the process by which the CPU retrieves, interprets, and executes instructions from the memory. 2. Control flow. It controls the flow of instructions in a program. The fetch phase retrieves the next instruction, the decode phase interprets it, and the execute phase carries it out. That's the control flow. That's the second importance of the fetch, decode, execute cycle. 3. Program execution. The FDE cycle allows a CPU to execute machine code instructions, which represents the lowest level commands that a computer understands. 4. Efficiency. By breaking down the execution of instructions into phases, the CPU can optimize performance through techniques like pipelining, where multiple instructions in different phases of execution simultaneously leading to improved throughput. The FDE cycle allows for error detection and handling. During the decode phase, the CPU can identify invalid or problematic instructions and handle them appropriately. The FDE cycle is also important to the CPU in such a way that it facilitates the possibility of executing multi-instructions in parallel, leading to a better performance in modern multi-core processors. So in all summary, the fetch, decode, execute cycle is the foundation of a CPU's ability to execute instructions, manage program flow, and perform the computation required for a computer to function. It is a fundamental concept in computer architecture, enabling the CPU to execute a wide range of tools effectively and accurately. This makes the FDE cycle, that's the fetch, decode, execute cycle, so crucial to the CPU, so fundamental to the CPU. This is an illustration of the fetch, decode, execute cycle diagram. As you can see displayed there, we have the fetch stage, the decode stage, all going through a process and a cycle in line. This is a nice detail of the fetch execute cycle. This is also a diagram, but this is a detailed diagram showing you the necessary information about the cycle. Thank you guys for listening.